AWS Session Number 3. EBS and EFS. Notes for AWS Solution Architect and SysOps Certification. By Cloud Dev. Date, April 27, 2020. 1. EBS Basics. While instance stores are an economical way to fulfill appropriate workloads, their limited persistence makes them ill-suited for many other workloads. Amazon EBS provides persistent block-level storage volumes for use with Amazon EC2 instances. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failure, offering high availability and durability. Multiple Amazon EBS volumes can be attached to a single Amazon EC2 instance, although a volume can only be attached to a single instance at a time. To get more performance out of EBS volumes 1. Use latest kernel 2. Use RAID 0. Volume remaining size is not in CloudWatch metric for EBS volumes. AWS CloudWatch logs can be used to monitor and store logs from EC2 instances. The instance needs OSLogs log driver installed to be able to send logs to CloudWatch. We don't need any database or S3 for storage. CloudWatch Logs agent is more efficient than AWS SSM agent. Placement groups cluster, spread max 7 per AZ, partitioned. The console does not support placement groups, have to do it from CLI. 1.1.1 Types of Amazon EBS volumes. Amazon EBS volumes are available in several different types. Types vary in areas such as underlying hardware, performance, and cost. It is important to know the properties of the different types so you can specify the most cost-efficient type that meets a workload's performance demands on the exam. 1.1.1.1 Magnetic volumes. Magnetic volumes have the lowest performance characteristics of all Amazon EBS volume types. As such, they cost the lowest per gigabyte. They are an excellent, cost-effective solution for appropriate workloads. A magnetic Amazon EBS volume can range in size from 1 GB to 1 TB and will average 100 IOPS, but has the ability to burst to hundreds of IOPS. They are best suited for workloads where data is accessed infrequently. Sequential reads. Situations where low-cost storage is a requirement. Magnetic volumes are built based on the amount of data space provisioned, regardless of how much data you actually store on the volume. 1.1.1.2 General Purpose SSD. General Purpose SSD volumes offer cost-effective storage that is ideal for a broad range of workloads. They deliver strong performance at a moderate price point that is suitable for a wide range of workloads. General Purpose SSD volumes under 1 TB also feature the ability to burst to up to 3000 IOPS for extended periods of time. For instance, if you have a 500 GB volume, you can expect a baseline of 1500 IOPS. Provisioned IOPS SSD. General Purpose SSD volumes are built based on the amount of data space provisioned, regardless of how much data you actually store on the volume. They are suited for a wide range of workloads where the very highest disk performance is not critical, such as system boot volumes, small to medium-sized databases, development and test environments. 1.1.1.3 Provisioned IOPS SSD. Provisioned IOPS SSD volumes are designed to meet the needs of I/O intensive workloads, particularly database workloads that are sensitive to storage performance and consistency in random access I/O throughput. While they are the most expensive Amazon EBS volume type per gigabyte, they provide the highest performance of any Amazon EBS volume type in a predictable manner. A provisioned IOPS SSD volume can range in size from 4 GB to 16 TB. When you provision a provisioned IOPS SSD volume, you specify not just the size, but also the desired number of IOPS, up to the lower of the maximum of 30 times the number of GB of the volume, or 20,000 IOPS. You can stripe multiple volumes together in a RAID 0 configuration for larger size and greater performance. Amazon EBS delivers within 10% of the provisioned IOPS performance 99.9% of the time over a given year. An additional monthly fee is applied based on the number of IOPS provisioned, whether they are consumed or not. Provisioned IOPS SSD volumes provide predictable, high performance and are well suited for critical business applications that require sustained IOPS performance. Large database workloads. Solid-state drives, SSD. Hard disk drives, HDD. Volume type. General Purpose SSD, GP2, *. Provisioned IOPS SSD, IO1. Throughput Optimized HDD, ST1. Cold HDD, SC1. Description. General Purpose SSD volume that balances price and performance for a wide variety of workloads. Highest performance SSD volume for mission-critical low latency or high throughput workloads. Low-cost HDD volume designed for frequently accessed, throughput-intensive workloads. Lowest cost HDD volume designed for less frequently accessed workloads. Use cases. Recommended for most critical business applications that streaming workloads requiring Throughput-oriented storage for large volumes. Workloads. System boot volumes. Virtual desktops. Low-latency interactive apps. Development and test environments. Require sustained IOPS performance, or more than 16,000 IOPS or 250 MIPS/s of throughput per volume. Large database workloads, such as MongoDB, Cassandra, Microsoft SQL Server, MySQL, PostgreSQL, Oracle. Consistent, fast throughput at a low price. Big data. Data warehouses. Log processing. Cannot be a boot volume of data that is infrequently accessed. Scenarios where the lowest storage cost is important. Cannot be a boot volume. API name. GP2. IO1. ST1. SC1. Volume size. 1 GB, 16 TB. 4 GB, 16 TB. 500 GB, 16 TB. 500 GB, 16 TB. Max IOPS/volume. 16,000. 64,000. 500. 250. Max throughput/volume. 250 MIPS/s. 1000 MIPS/s. 500 MIPS/s. 250 MIPS/s. Max IOPS/instance. 80,000. 80,000. 80,000. 80,000. Max throughput/instance. 1750 MIPS/s. 1750 MIPS/s. 1750 MIPS/s. 1750 MIPS/s. Dominant performance attribute. IOPS. IOPS. MIPS/s. MIPS/s. IOPS in MB/SEC. IOPS input/output per second. Useful for random workloads. Useless without latency figures. I/Os come in all shapes and sizes. Read or write. Big or small. Random or sequential. 1.1.2 Protecting data/encryption. Over the life cycle of an Amazon EBS volume, there are several practices and services that you should know about when taking the exam. 1.1.2.1 EBS encryption. https://aws.amazon.com/blog/aws/new encrypted EBS boot volumes/ encrypted EBS boot volumes. December 15, 2015. Today we are launching encryption for EBS boot volumes. This feature builds on a recent release that allowed you to copy an EBS snapshot while also applying encryption. You can now create Amazon Machine Images, AMIS, that make use of encrypted EBS boot volumes and use the AMIS to launch EC2 instances. The stored data is encrypted, as is the data transfer path between the EBS volume and the EC2 instance. The data is decrypted on the instance on an as-needed basis, then stored only in memory. Further, because this feature makes use of KMS, you can track and audit all uses of the encryption keys. Because EBS already supports encryption of data volumes, and by implication the snapshots associated with the volumes, you can now create a single AMI with a fully encrypted set of volumes. 1.1.2.2 Amazon EBS Snapshot. You can back up the data on your Amazon EBS volumes to Amazon S3 by taking point-in-time snapshots. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshot are saved. This minimizes the time required to create the snapshot and saves on storage costs by not duplicating data. Each snapshot contains all of the information that is needed to restore your data, from the moment when the snapshot was taken, to a new EBS volume. Multi-volume snapshots. Multi-volume snapshots allow you to take exact point-in-time, data-coordinated, and crash-consistent snapshots across multiple EBS volumes attached to an EC2 instance. You are no longer required to stop your instance or to coordinate between volumes to ensure crash consistency, because snapshots are automatically taken across multiple EBS volumes. You can track the status of your EBS snapshots through CloudWatch events. How incremental snapshots work. In State 1, the volume has 10 GB of data. Because Snap A is the first snapshot taken of the volume, the entire 10 GB of data must be copied. In State 2, the volume still contains 10 GB of data, but 4 GB have changed. Snap B needs to copy and store only the 4 GB that changed after Snap A was taken. The other 6 GB of unchanged data, which are already copied and stored in Snap A, are referenced by Snap B rather than, again, copied. This is indicated by the dashed arrow. In State 3, 2 GB of data have been added to the volume, for a total of 12 GB. Snap C needs to copy the 2 GB that were added after Snap B was taken. As shown by the dashed arrows, Snap C also references 4 GB of data stored in Snap B, and 6 GB of data stored in Snap A. The total storage required for the 3 snapshots is 16 GB. 1.1.2.3 Backup/recovery, snapshots. You can back up the data on your Amazon EBS volumes, regardless of volume type, by taking point-in-time snapshots. Snapshots are incremental backups, which means that only the blocks on the device that have changed since your most recent snapshot are saved. Taking snapshots. You can take snapshots in many ways. Through the AWS Management Console. Through the CLI. Through the API. By setting up a schedule of regular snapshots. When you request a snapshot, the point-in-time snapshot is created immediately and the volume may continue to be used, but the snapshot may remain in pending status until all the modified blocks have been transferred to Amazon S3. Snapshots are constrained to the region in which they are created, meaning you can use them to create new volumes only in the same region. Creating a volume from a snapshot. When you do this, the volume is created immediately but the data is loaded lazily. This means that the volume can be accessed upon creation, and if the data being requested has not yet been restored, it will be restored upon first request. Because of this, it is a best practice to initialize a volume created from a snapshot by accessing all the blocks in the volume. Snapshots can also be used to increase the size of an Amazon EBS volume. To increase the size of an Amazon EBS volume, take a snapshot of the volume, then create a new volume of the desired size from the snapshot. Replace the original volume with the new volume. 1.1.2.4 Recovering volumes. Because Amazon EBS volumes persist beyond the lifetime of an instance, it is possible to recover data if an instance fails. If an Amazon EBS-backed instance fails and there is data on the boot drive, it is relatively straightforward to detach the volume from the instance. Unless the delete on termination flag for the volume has been set to false, the volume should be detached before the instance is terminated. 1.1.2.5 Amazon EBS Snapshot Restore. You can restore an Amazon EBS volume with data from a snapshot stored in Amazon S3. You must know the ID of the snapshot and you must have access permissions for the snapshot. EBS snapshots are the preferred backup tool on Amazon EC2 due to their speed, convenience, and cost. 1.1.2.6 Encryption Options. Many workloads have requirements that data be encrypted at rest, either because of compliance regulations or internal corporate standards. Amazon EBS offers native encryption on all volume types. The encryption that hosts Amazon EC2 instances, so the data is actually encrypted in transit between the host and the storage media and also on the media. 1.1.3 Summary. Compute is the amount of computational power required to fulfill your workload. Amazon EC2 is the primary service for providing compute to customers. The instance type defines the virtual hardware supporting the instance. Available instance types vary in vPUS, memory, storage, and network performance to address nearly any workload. ANAMI defines the initial software state of the instance, both OS and applications. There are 4 sources of AMOS: AWS published generic OSs, partner-published AMOS in the AWS Marketplace with software packages pre-installed, customer-generated AMOS from existing Amazon EC2 instances, and uploaded AMOS from virtual servers. Instances can be addressed by public DNS name, public IP address, or elastic IP address. To access a newly launched Linux instance, use the private half of the key pair to connect to the instance via SSH. To access a newly created Windows instance, use the private half of the key pair to decrypt the randomly initialized local administrator password. Network traffic in and out of an instance can be controlled by a virtual firewall called a security group. A security group allows rules that block traffic based on direction, port, protocol, and source/destination address. Bootstrapping allows you to run a script to initialize your instance with OS configurations and applications. This feature allows instances to configure themselves upon launch. Once an instance is launched, you can change its instance type or, for Amazon VPC instances, the security groups with which it is associated. The 3 pricing options for instances are On-Demand, Reserved Instance, and Spot. On-Demand has the highest per hour cost, requiring no upfront commitment and giving you complete control over the lifetime of the instance. Reserved instances require a commitment and provide a reduced overall cost over the lifetime of the reservation. Spot instances are idle compute capacity that AWS makes available based on bid prices from customers. The savings on the per hour cost can be significant, but instances can be shut down when the bid price exceeds the customer's current bid. Instance stores are block storage included with the hourly cost of the instance. The amount and type of storage available varies with the instance type. Instance stores terminate when the associated instance is stopped, so they should only be used for temporary data or in architectures providing redundancy such as AWS HDFS. Amazon EBS provides durable block storage in several types. Magnetic has the lowest cost per gigabyte and delivers modest performance. General purpose SSD is cost-effective storage that can provide up to 10,000 IOPS. Provisioned IOPS SSD has the highest cost per gigabyte and is well suited for I/O intensive workloads sensitive to storage performance. Snapshots are incremental backups of Amazon EBS volumes stored in Amazon S3. Amazon EBS volumes can be encrypted. 1.1.4 Relationship between storage and your instance. Amazon EBS provides durable, block-level storage volumes that you can attach to a running instance. An EBS volume behaves like a raw, unformatted, external block device. EBS persists independently from the running life of an instance. You can also detach an EBS volume from one instance and attach it to another instance. EBS volumes can also be created as encrypted volumes. To keep a backup copy of your data, you can create a snapshot of an EBS volume, which is stored in Amazon S3. EBS Lab. Vol Type. 1.1.5 Create Snapshot Lifecycle Policy. Amazon EC2 Instance Store. Many instances can access storage from disks that are physically attached to the host computer. Instance Store provides temporary block-level storage for instances. The data on an instance store volume persists only during the life of the associated instance. If you stop or terminate an instance, any data on instance store volumes is lost. Instance Store is ideal for temporary storage of information that changes frequently, such as buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. The virtual devices for instance store volumes are ephemeral 0 to 23. Instance Store Lifetime. You can't detach an instance store volume from one instance and attach it to a different instance. If an instance reboots, intentionally or unintentionally, data in the instance store persists. However, data in the instance store is lost under any of the following circumstances. O. The underlying disk drive fails. O. The instance stops. O. The instance terminates. This is end of EBS notes. Hope it will be useful to you. For further details, please visit AWS documentation pages. Now, let us start a new learning objective. You can pause video for 5 minutes and start new learning. 2. Elastic File System EFS. Scalable, elastic, cloud-native file system for Linux. Linux-based workloads for use with AWS cloud services and on-premises resources. Built to scale on demand to petabytes without disrupting applications, growing and shrinking automatically as you add and remove files. You can access your file systems across AZs, regions, and VPCs and share files between thousands of Amazon EC2 instances and on-premises servers via AWS Direct Connect or AWS VPN. Reducing storage costs by up to 85%. Between Standard and IA. The Standard storage class is used to store frequently accessed files. The Infrequent Access, IA, storage class is a lower-cost storage class that's designed for storing long-lived, infrequently accessed files cost-effectively. EFS provides features like strong data consistency and file locking. Support POSIX permission. RWX type. Amazon EFS is a regional service storing data within and across multiple availability zones, AZs, for high availability and durability. Choose throughput mode. Bursting, default and AWS recommended, 100 MB/s till 1 TB. For example, a 10-tip file system can burst to 1000 MB/s of throughput. Provisioned. Use provisioned throughput mode for applications that require more throughput than allowed by bursting throughput. Choose performance mode. General purpose. Provisioned. The bursting model is designed so that typical file system workloads can burst virtually any time they need to. AWS credit system for EFS. The baseline rate is 50 MB/s per tib of storage, equivalently, 50 KB/s per gig of storage. Accumulated burst credits give the file system the ability to drive throughput above its baseline rate. You can use KMS keyarn from another account also. Benefits. Dynamic elasticity. Amazon EFS automatically and instantly scales your file system storage capacity up or down as you add or remove files without disrupting your applications. Scalable performance. Amazon EFS can support performance over 10 GB/SEC and up to 500,000 IOPS. Shared file system. Via NFS v4, permissions model, file locking capabilities. Fully managed. Cost effective. With lifecycle management, you can automatically move files that have not been accessed for 30 days to a cost-optimized storage class, reducing storage costs by up to 85%. Secure in compliance, POSIX, VPC, and IAM, port 2049. Figure 1 How EFS works. 2.1 Use cases. 2.1.1 Lift and Shift Enterprise Applications. Amazon EFS provides the scalability, elasticity, availability, and durability to be the file store for enterprise applications and for applications delivered as a service. Its standard file system interface, file system permissions, and directory hierarchy make it easy to migrate enterprise applications from on-premises to the AWS cloud or to build new ones. 2.1.2 Big Data Analytics. Amazon EFS provides the scale and performance for big data applications that require high throughput to compute nodes coupled with read-after-write consistency and low latency file operations. Many analytics workloads interact with data via a file interface, requiring file permissions, a directory hierarchy, file locks, and the ability to write to portions of a file. Amazon EFS provides the necessary file system security and can scale capacity as well as performance to support the demands of big data analytics workloads. 2.1.3 Web Serving and Content Management. Amazon EFS provides a durable, high-throughput file system for content management systems and web serving applications that store and serve information for a range of applications like websites, online publications, and archives. Since Amazon EFS adheres to the expected file system directory structure, file naming conventions, and permissions that web developers are accustomed to, it can easily integrate with web applications. 2.1.4 Application Testing and Development. Amazon EFS provides your development environments a common storage repository that gives you the ability to share code and other files in a secure and organized way. You can provision, duplicate, scale, or archive your test, development, and production environments with a few clicks, enabling your organization to be more agile and responsive to customer needs. Amazon EFS delivers a scalable and highly available solution that is ideal for testing and development workloads. 2.1.5 Media and Entertainment. Media workflows like video editing, studio production, broadcast processing, sound design, and rendering often depend on shared storage to manipulate large files. Amazon EFS provides a strong data consistency model with high throughput and shared file access, which can cut the time it takes to perform these jobs and consolidate multiple local file repositories into a single location for all users. 2.1.6 Database Backups. Amazon EFS presents a standard file system that can be easily mounted with NFS-v4 from database servers. This provides an ideal platform to create portable database backups using native application tools or enterprise backup applications. Many businesses want to take advantage of the flexibility of storing database backups in the cloud either for temporary protection during updates or for development and test. 2.1.6.1 AWS Data Sync. AWS Data Sync is a managed data transfer service that makes it faster and simpler to move data between on-premises storage and Amazon EFS. You can use Data Sync to transfer active datasets over AWS Direct Connect or the Internet at speeds up to 10 times faster than open-source tools. It does this without the need for you to modify your applications or write to an API. You can use the service for one-time data migrations, ongoing workflows with periodic synchronization, and replication for data protection and recovery. Data Sync automatically handles many of the tasks that can slow down migrations or burden your IT operations, including infrastructure management, encryption, data validation, and data transfer orchestration. 2.1.6.2 AWS Backup. AWS Backup is a fully managed backup service that makes it easy to centrally manage and automate backups of your Amazon EFS file systems, removing the need for costly, custom solutions and manual processes. AWS Backup goes beyond backing up Amazon EFS and centralizes the backup of data across other AWS services in the cloud as well as on-premises. As applications move to the cloud, their data can become distributed across multiple services, making it difficult to manage and consolidate backup activity without creating custom scripts and manual processes. Using AWS Backup, you can centrally configure and audit AWS resources, automate backup scheduling, set retention policies, and monitor backup activity. 2.1.7 Container Storage. Amazon EFS is ideal for container storage, providing persistent shared access to a common file repository. Containers are an integral part of building microservices because they're quick to provision, easily portable, and provide process isolation. Containers that need access to the original data each time they start can take advantage of a shared file system that they can connect to regardless of which instance they're running on. 2.1.8 Lab. Figure 2 EFS Start Screen. Figure 3 Create EFS in VPC and desired AZ. 2.1.9 FAQ Amazon Elastic File System, EFS. How do I access a file system from an Amazon EC2 instance? You mount the file system on an Amazon EC2 Linux-based instance using the standard Linux mount command in the file system's DNS name. Amazon EFS uses the NFS v4.1 protocol. Amazon EFS is compatible with all Amazon EC2 instance types and is accessible from Linux-based AMOS. How do I load data into a file system? You can load data into an Amazon EFS file system from your Amazon EC2 instances or from your on-premises data center servers. To load data that is not currently stored on the Amazon cloud, you can use the same methods you use to transfer files to Amazon EC2 today, such as Secure Copy, SCP. Amazon EFS file systems can also be mounted on an on-premises server, so any data that is accessible to an on-premises server can be read and written to Amazon EFS using standard Linux tools. How do I access my file system from outside my VPC? Amazon EC2 instances within your VPC can access your file system directly, and Amazon EC2 Classic instances outside your VPC can mount a file system via Classic link. On-premises servers can mount your file systems via an AWS Direct Connect connection to your VPC. How many Amazon EC2 instances can connect to a file system? Amazon EFS supports 1 to thousands of Amazon EC2 instances connecting to a file system concurrently. Elastic IP. Why am I limited to 5 Elastic IP addresses per region? There is only a limited amount of public IP space available, and Amazon EC2 is committed to helping use that space efficiently. By default, all accounts are limited to 5 Elastic IP addresses per region. In order to help ensure our customers are efficiently using the Elastic IP addresses, we impose a small hourly charge for each address when it is not associated to a running instance. Do I need one Elastic IP address for every instance that I have running? No. You do not need an Elastic IP address for all your instances. By default, every instance comes with a private IP address and an internet routable public IP address. How long does it take to remap an Elastic IP address? The remap process currently takes several minutes from when you instruct us to remap the Elastic IP until it fully propagates through our system. Can I configure the reverse DNS record for my Elastic IP address? All Elastic IP addresses come with reverse DNS. What use cases does Amazon EFS support? Designed to provide performance for including big data and analytics, media processing workflows, content management, web serving, and home directories. Why EFS? Amazon EFS is a file storage service for use with Amazon EC2. Amazon EFS provides a file system interface, file system access semantics, such as strong consistency and file locking, and concurrently accessible storage for up to thousands of Amazon EC2 instances. How do I access a file system from an Amazon EC2 instance? You mount the file system on an Amazon EC2 Linux-based instance using the standard Linux mount command and the file system's DNS name. To simplify accessing your EFS file systems, we recommend using the EFS Mount Helper utility. Amazon EFS uses the Network File System version 4, NFS-v4, protocol. February 1st, 10 storage classes and lifecycle management. What storage classes does Amazon EFS offer? Amazon EFS offers a standard and an infrequent access storage class. The standard storage class is designed for active file system. EFS Infrequent Access, EFSIA, is a lower-cost storage class that's cost-optimized for files not accessed every day. EFS Infrequent Access is 85% cheap W.R.T standard EFS. How do I move files to EFSIA? Moving files to EFSIA starts by enabling EFS Lifecycle Management and choosing an H-off policy. For example, you can automatically move files into EFSIA 14 days of not being accessed. When should I enable Lifecycle Management? When your file system contains files that are not accessed every day. Files smaller than 128 KB are not eligible for Lifecycle Management and will always be stored on EFS Standard. EFS Standard is designed to provide single-digit latencies on average, and EFSIA is designed to provide double-digit latencies on average. What throughput can I drive against files stored in the EFS Infrequent Access Storage class? All EFS file systems, regardless of size, can burst to 100 MB/s of throughput. If you require higher amounts of throughput to EFSIA than your file system allows, use EFS Provision Throughput. February 1st, 11 Data Protection and Availability. How is Amazon EFS designed to provide high durability and availability? Redundantly stored across multiple availability zones. How do I back up a file system? You can use AWS Backup. How do I access my file system from outside my VPC? Amazon EC2 instances within your VPC can access your file system directly. Amazon EC2 Classic instances outside your VPC can mount a file system via Classic link. Amazon EC2 instances in other VPCs can access your file system if connected using a VPC peering connection or VPC transit gateway. On-premises servers can mount your file systems via an AWS Direct Connect or AWS VPN connection to your VPC. February 1st, 12 Scale and Performance. How much data can I store? Petabytes. Amazon EFS file systems are elastic, and automatically grow and shrink as you add and remove files. How many Amazon EC2 instances can connect to a file system? Up to 1,000. How many file systems can I create? 1,000 file system per region. How does Amazon EFS performance compare to that of other storage solutions? Amazon EFS's distributed design avoids the bottlenecks and constraints inherent to traditional file servers. This distributed data storage design means that multi-threaded applications that concurrently access data from multiple Amazon EC2 instances can drive substantial levels of aggregate throughput and IOPS. Amazon EFS. Amazon EBS, IO1. Per operation latency. Low, consistent. Lowest, consistent. Throughput scale. Multiple GBs per second. Single GB per second. Amazon EFS's distributed nature enables high levels of availability, durability, and scalability. This distributed architecture results in a small latency overhead for each file operation. Amazon EFS's support for highly parallelized workloads, i.e. with consistent operations from multiple threads and multiple EC2 instances, enables high levels of aggregate throughput and IOPS. What's the difference between general purpose and max IO performance modes? Which one should I choose? General purpose performance mode is appropriate for most file systems, and is the mode selected by default when you create a file system. Max IO performance mode is optimized for applications where tens, hundreds, or thousands of EC2 instances are accessing the file system. It scales to higher levels of aggregate throughput and operations per second with a trade-off of slightly higher latencies for file operations. How much throughput can a file system support? Amazon EFS is designed to burst to allow high throughput levels for periods of time. 50 MB/s per TB can burst to 100 MB/s and can burst to 100 MB/s with more than 1 TB of standard class storage can burst to 100 MB/s per TB. February 1st, 13 Provision throughput. What is provision throughput and when should I use it? Provision throughput enables Amazon EFS customers to provision their file systems throughput. Amazon EFS provision throughput is available for applications with a high throughput to storage, MB/s per TB, ratio. How does Amazon EFS provision throughput work? It provided required IOPS capacity with extra charge. How do I control which Amazon EC2 instances can access my file system? When you create a file system, you create endpoints in your VPC called mount targets. You can control the network traffic to and from your file system mount targets using VPC security groups. Only resources that can access a mount target can access your file system. How do I control who can access my file system? IAM. February 1st, 14 Encryption. What is Amazon EFS encryption? Ability to encrypt data at rest and in transit. Encryption keys are managed by the AWS Key Management Service, KMS, eliminating the need to build and maintain a secure key management infrastructure. Data encryption in transit uses industry standard transport layer security, TLS, 1.2. How do I enable encryption for my Amazon EFS file system? While creating a new file system in the EFS console, click Create File System and click the checkbox to enable encryption. Data can be encrypted in transit between your Amazon EFS file system and its clients by using the EFS mount helper. Does encryption impact Amazon EFS performance? Minimal effect on I/O latency and throughput. February 1st, 15 On-premises access. How do I access an EFS file system from servers in my on-premises data center? An AWS Direct Connect or AWS VPN connection between your on-premises data center and your Amazon VPC. Mount an EFS file system via the NFS v4.1 protocol. What can I do by enabling access to my EFS file systems from my on-premises servers? Move file data to and from Amazon EFS using standard Linux tools and scripts or AWS Data Sync. EFS use case. You can migrate data from on-premises data centers to permanently reside in Amazon EFS file systems. You can support cloud bursting workloads to offload your application processing to the cloud. You can periodically copy your on-premises file data to EFS to support backup and disaster recovery scenarios. Can I access my Amazon EFS file system concurrently? Yes. Amazon EFS provides the same file system access semantics, such as strong data consistency and file locking, across all EC2 instances and on-premises servers accessing a file system. What is the recommended best practice when moving file data to and from on-premises servers? Latency could be high for on-premises. To maximize your throughput, parallelize your file operations so that multiple reads and writes are processed by EFS concurrently. How do I copy existing data from on-premises file storage to Amazon EFS? AWS Data Sync provides a fast and simple way to securely sync existing file systems into Amazon EFS and works over any network, including AWS Direct Connect. AWS Direct Connect provides a high bandwidth and lower latency dedicated network connection over which you can mount your Amazon EFS file systems. Once mounted, you can use Data Sync to copy data into Amazon EFS up to 10x faster than standard Linux copy tools. This ends EFS summary notes here. Let's start new learning objective. February 1st, 16 AWS Data Sync. What is AWS Data Sync? Is an online data transfer service that makes it faster and simpler to move data between on-premises storage and Amazon EFS. Data Sync uses a purpose-built protocol to accelerate and secure transfer over the internet or AWS Direct Connect, at speeds up to 10 times faster. Using Data Sync you can perform one-time data migrations, transfer on-premises data for timely in-cloud analysis, and automate replication to AWS for data protection and recovery. How do I copy data into or out of my EFS file system with AWS Data Sync? To get started with AWS Data Sync, you first deploy a software agent that is available for download from the AWS Management Console. Once deployed, you can use the console or AWS Command Line Interface, CLI, to connect the agent to your on-premises or in-cloud file systems using the Network File System, NFS, protocol. Select your Amazon EFS file system, and start copying data. Can EFS data be copied between regions with AWS Data Sync? Yes. February 1st, 17 compatibility. What interoperability and compatibility is there between existing AWS services and Amazon EFS? Amazon CloudWatch, AWS CloudFormation, AWS CloudTrail, AWS IAM, and AWS tagging services. What type of logging does Amazon EFS support? NFS v4.1 protocol. Are file system names global, like Amazon S3 bucket names? Automatically generated ID number that is globally unique. Now let's go through FAQ session. This is very important for exam point of view. 2.2 EBS FAQ. What happens to my data when a system terminates? Persists if you select Y while creating EC2, otherwise it will get deleted as per your choice. What kind of performance can I expect from Amazon EBS volumes? SSD-backed storage for transactional workloads and HDD-backed storage for throughput-intensive workloads. What are throughput-optimized HDD, ST1, and cold HDD, SC1, volume types? ST1 volumes are backed by hard disk drives, HDDs, and are ideal for frequently accessed, throughput-intensive workloads with large datasets and large I/O sizes, such as MapReduce, Kafka, log processing, data warehouse, and ETL workloads. These volumes deliver performance in terms of throughput, measured in MB/s, and include the ability to burst up to 250 MB/s per TB. With a baseline throughput of 40 MB/s per TB and a maximum throughput of 500 MB/s per volume. ST1 is designed to deliver the expected throughput performance 99% of the time and has enough I/O credits to support a full volume scan at the burst rate. Which volume type should I choose? SD-backed storage, transactional, IOPS-intensive database workloads, boot volumes, and workloads that require high IOPS, HDD-backed volumes, throughput-intensive and big data workloads, large I/O sizes, and sequential I/O patterns. Are snapshots versioned? Can I read an older snapshot to do a point-in-time recovery? Each snapshot is given a unique identifier, and customers can create volumes based on any of their existing snapshots. Do you offer encryption on Amazon EBS volumes and snapshots? Yes. EBS offers seamless encryption of data volumes and snapshots. EBS encryption better enables you to meet security and encryption compliance requirements. You can attach a network interface, ENI, to an EC2 instance in the following ways. When it's running, hot attach. When it's stopped, warm attach. When the instance is being launched, cold attach. EBS snapshots are a more efficient and cost-effective solution compared to disk mirroring using RAID1. EBS volumes can only be attached to an EC2 instance in the same availability zone. Using RAID configurations, we should stop every I/O operation and flush the cache before taking a snapshot. Larger EC2 instances have higher disk data throughput. This can be used in conjunction with RAID 0 to improve EBS performance. 2.2.1 Instance Type. 2.2.1.1 General Purpose. A1. Custom-built AWS Graviton processor with 64-bit ARM Neoverse cores. Support for enhanced networking with up to 10 Gbps of network bandwidth. EBS optimized by default. Powered by the AWS Nitro system, a combination of dedicated hardware and lightweight hypervisor. 2.2.1.2 Compute optimized. C5. 2.2.1.3 Memory optimized. R5. 2.2.1.4 Accelerated computing. P3. 2.2.1.5 Storage optimized. I3. 2.2.2 Instance features. Amazon EC2 instances provide a number of additional features to help you deploy, manage, and scale your applications. 2.2.2.1 Burstable performance instances. Amazon EC2 allows you to choose between fixed performance instances, e.g. M5, C5, and R5, and burstable performance instances, e.g. T3. Burstable performance instances provide a baseline level of CPU performance with the ability to burst above the baseline. Unlimited instances can sustain high CPU performance for as long as a workload needs it. If the instance needs to run at higher CPU utilization for a prolonged period, it can do so at a flat additional charge of 5 cents per VPU hour. T instances accrue CPU credits when they are idle, and use CPU credits when they are active. A CPU credit provides the performance of a full CPU core for 1 minute. 2.2.2.2 Multiple storage options. Amazon EC2 allows you to choose between multiple storage options based on your requirements. Amazon EBS is a durable, block-level storage volume that you can attach to a single, running Amazon EC2 instance. 2.2.2.3 EBS Optimized Instances. For an additional, low, hourly fee, customers can launch selected Amazon EC2 instances types as EBS Optimized Instances. For C5, C4, M5, M4, P3, P2, G3, and D2 instances, this feature is enabled by default at no additional cost. 2.2.2.4 Cluster Networking. Select EC2 instances support cluster networking when launched into a common cluster placement group. Inter-instance traffic within the same region can utilize up to 5 Gbps for single flow and up to 25 Gbps for multi-flow traffic in each direction, full duplex. When launched in a placement group, instances can utilize up to 10 Gbps for single flow traffic and up to 25 Gbps for multi-flow traffic. Network traffic to the internet is limited to 5 Gbps, full duplex. Cluster networking is ideal for high-performance analytics systems and many science and engineering applications, especially those using the MPI library standard for parallel programming. 2.3 Additional Notes EFS. 2.3.1 Notes. EFS needed just 2049 port. Inter-region VPC supported by EFS. Encryption of EFS, it can be done during EFS creation. EFS Transit Encryption, use Mount Helper. EFS supports cross-availability zone mounting, but it is not recommended. The recommended approach is creating a mount point in each availability zone. You can mount an EFS file system in only one VPC at a time. If you want to access it or mount it from another VPC, you have to create a VPC peering connection in one region. With this we reached the end of session. I hope this will you in preparing an exam. Kindly share your comments/feedback. I wish all the best for success of exam and great future.